So I just took that integral. It's undefined at 1. And so since it's undefined at 1, the function, I'm splitting it. And then 1 is that part that's causing an issue, so that's what we're going to turn into a limit. So this is going to turn into the limit. And again, I said usually, yeah, so this is still part of, this is part of, I think 9.7 sounds right. It's the last section we were doing. Let me look it up. I can tell you what section it is. But 9.7 sounds correct. Yeah, this is part of 9.7. So I usually replace upper limits with a b and lower limits with an a. So this is going to be the limit as b approaches 1 of the integral from 0 to b of dx over x minus 1 to the 2/3 plus the limit as a approaches 1 of the integral from a to 3 of dx over x minus 1 to the 2/3. You could have picked b for both pieces in this case. A lot of times we have things going to positive infinity and negative infinity, and so then for sure we want an a and a b. I just left it as an a and b since that's what we had been doing. And so for both of these problems, we're going to have to integrate that integral. So I'm just going to come over here on the side, and I'm going to figure out what that integral is here on the side. So we're looking to integrate dx over x minus 1 to the 2/3. So does anybody have any idea how I would go about integrating dx over x minus 1 to the 2/3? Okay. So we can make it x minus 1 to the negative 2/3 dx. Sure. Yeah, and then from there I could do a u substitution, right? You might be actually at a point where you're like, I know what's going to happen if I do the u substitution. So you might be at a point where you're like, I don't need to do the u substitution to write down what the answer is. That's fine. But yeah, it's a u substitution problem. So we're going to let u be x minus 1. So du is going to be dx. So this is just going to turn into the integral of u to the minus 2/3 du. And then we would add 1. So it's going to be u to the 1/3 over 1/3. And I'm not going to worry about a plus c or stuff because I'm just kind of trying to figure out what the integral is. And then we're going to plug it back into the limits over there into that other side. And so this is really 3, and then u is x minus 1. So 3 times x minus 1 to the 1/3 power. Questions on my integral at all? No. Okay, so this is going to be the limit as b approaches 1 of 3 times x minus 1 to the 1/3 evaluated from 0 to b plus the limit as a approaches 1 of 3 times x minus 1 to the 1/3 evaluated from a to 3. And then we're just going to plug in the top number, subtract off plugging in the bottom number. So we've got the limit as b approaches 1 of 3 times b minus 1 to the 1/3 minus 3 times 0 minus 1 to the 1/3 plus the limit as a approaches 1 of 3 times 3 minus 1 to the 1/3 minus 3 times a minus 1 to the 1/3. Questions? No? Sure. Yeah. I can pause for a minute here. Let me know when you're ready, and then I'll go from there. Okay. Anybody else have any other questions or anything?
Professor, I have a question.
Sure.
Sorry, I think I missed this. At the beginning, you have the definite integral of 3 over 0. How did you change that to the integral of 1 over 0 plus the integral of 3 over 1?
Okay, so the thing is that the first thing you want to notice is that here, the this function, so like forget about the dx part, but if you think of the function 1 over x minus 1 to the 2/3 power, this is undefined, right, when x is 1. So if you were to plug in 1, you would get 1 over 0. So so 1 is a problem area. So I'm trying to integrate over a space where there's a problem area. So that's the first thing that, like, that tells me I have to split the integral. So I split it. This goes back to Calc 1. So in Calc 1, you learned that the integral from, so in Calc 1, you do things like the integral from, a to b of f of x dx is equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. So as long as these, the top and the bottom here, match, then you can split an integral into two pieces. So that's what allowed me to then split the integral into two pieces, and that works because part of my issue is when x equals 1. And so this way I don't have to, now I have the 1 as one of the limits of integration, which then allows me to turn it into an actual limit problem. Does that help?
Yes, thank you.
No problem. Any other questions? No? Okay. So we're just gonna plug in the B being 1 and the A being 1, and as long as everything works out okay, like, that's all right. So we've got 3 times 1 minus 1 to the 1/3 minus, this is 3 times negative 1 to the 1/3 plus 3 times 2 to the 1/3 minus 3 times 1 minus 1 to the 1/3. And 1 minus 1 is 0. So these pieces here end up going to 0 because we just have 0 to the 1/3 power, which is 0. The 1/3 power, remember, the 1/3 power is talking about taking a cube root. So this is really saying I have negative 3 cube root of negative 1 plus 3 cube root of 2. And the cube root of negative 1 is negative 1. So this whole first piece is just going to turn out to be a positive 3 plus 3 cube root of 2. So each of the pieces worked out to be a number. And I could have done kind of how I was doing the other day, like worked one limit all the way out and then worked the other limit all the way out and added the two together. That's essentially what happened here, right? The 3 comes from the first integral and the 3 cube root of 2 comes from the second integral. And because I actually get a number, right? I didn't end up getting positive infinity or negative infinity as my answer. Remember, we say these converge. So this integral converges. And it converges to that number. So even though it's an improper integral, because at the beginning it has this like bad part in it, it does actually act kind of like a regular integral, and it converges to this number. Questions? Yeah, so remember the cube root is you're thinking of a number that when you multiply times itself 3 times gives you that number. So you want to think about what times itself, so like something times that same something, has to give you us -1. So that is -1, because -1 times -1 is a positive 1, times -1 is -1. Does that help?
Are we allowed to use a calculator during the test?
Yeah, you can use a calculator during the test. The thing I'm going to say, right, you're allowed to use a calculator. So you're allowed to use a calculator during the test. I have no problem with that. If you have a calculator where like you would just put this like into your calculator and it would just spit out 3 plus 3 cube root of 2, and there are calculators that do that, right? And that's all you put down on the test, you're going to get like no points for it. So you have to show the work. But in terms of like having a calculator so that you can find the cube root of -1, that's totally fine. And then, yeah, cube odd roots. So the only ones that become imaginary numbers are even roots. So square roots, fourth roots, sixth roots, eighth roots, so forth, those become imaginary numbers. But cube roots, odd roots, are allowed to be negative. Does that help? No problem. Other questions? So the next test is actually going to have everything on it. So that's a good segue. So let me pull up. So I'm going to go pull up the stuff about the test, and we'll talk about the test. But before I do that, does anyone have any other questions on this problem before I navigate away from it and answer questions about the test? No. Okay. So I'm going to stop sharing this. And let me share. Okay. So I did put up on Canvas. Then if you click on test review, you will see that the next test information is here. So the test is Tuesday, March 2nd. So it covers, if you click on this, it's going to talk to, I'm going to show you. Okay, so you have to be able to integrate all the different types of techniques of integration that we have. So you have to be able to use regular integration, algebra, like any kind of, do some fancy algebra, use substitution. So that's kind of still the stuff from Calc 1. So like kind of like think about like everything that was on the last test. So regular integration, algebra, use substitution, and parts. And then since then, we've also added trig integrals, trig substitution, and partial fractions. Then we also did L'Hopital's rule, right? And then we also did determine whether an improper integral converges or diverges. And I have here for you a bunch of, oops, let me move this. So I have here a bunch of practice problems, right? So there's a bunch of different integrals for you to practice, then evaluate the following improper integrals, and then find the following limits. Okay, so yes, so the handout, and I didn't put it up yet, the actual one for the test, but within the test environment in Canvas, I will have, so if we go back to the home page, and if we go back to handouts, so here under handouts, right, so there is this handout that says trig integrals helpful information. Okay, so this handout, right, you can, so I will have a handout that basically it won't have this part here. It won't have the strategies for integrating, but it will have all of this stuff up here. So it'll have the reduction formulas, the useful trig integrals, and then if you continue on, it'll have the useful integrals, it'll have more reduction formulas, more useful trig identities. It just won't have the strategies for integrating on the sheet. So it'll have everything else. Other questions about the test? Okay, no problem. And then just like before, right, if let's see. Let's see. Go back home. Okay. So just like before, oops, that's right. That's because I went off of that page. Okay. So under the test review, there is also, so there is the problems, but then there's also the my solutions, right? Dr. Gorman's worked out answers to the review sheet. And Thursday's class will just be review for the test. So I will do whatever kind of problems, answer anything you want me to answer, on Thursday. Today, what we are going to do is, so if I go back to the home page. Okay, so up under handouts, so go back to handouts, so you guys can all access this. So under handouts, and I can leave my screen up, but I don't know once I put us into breakout rooms if you'll still be able to see my screen or not. But I have here integration in class practice 223. Right, so I have here 10. Okay, I have here 10 problems for us to basically try to work on for the rest of class. So couple points about it. So what I'm going to do is I am going to put you guys into breakout rooms, and I will let you work together and kind of work on the problems. I will, after class, put up the answers for these. So I do have the answers to these all worked out. I'm not going to put them up to begin with because I want you guys to try to work on them. So what will happen is once I put you into breakout rooms, like you can call me or Brian to a breakout room. So I'm going to hop around and then Brian might come and help me out some. But I'm going to hop around. And so if you need help on a problem, you're stuck, you guys have questions on it. Like you can basically, there's a thing that says like call the host or call Dr. Gorman to your room. So you can call us to your room. And so that we can help you out. So yeah, that's the only thing I don't know what will happen. I mean, so let me just share the PDF, as opposed to, and let me see, I might be able to, let me share. So let me open these problems in Adobe, and then I probably can share the screen from there. So, oops. My thing is I don't know if once I put you in a, and I'm just gonna make it a little bit. Oh, I can. Let me view full screen. Okay. I think I can make that a little bit bigger. All right. So, yeah, you can download the PDF from Canvas. I have this up here. I don't know what's going to happen when I put you in a breakout room. I don't know if this document is still going to stick around when I stick you in a breakout room or not. That's the only thing. So that being said, so kind of what we're going to do is I'm going to let you guys work together, kind of for like the next hour. So until about like 3:20 or so a little bit shorter than an hour. And then that way will kind of come back together. So if there's any problems you want me to do, I can do a couple problems like after that. A couple things. If you are somebody who's like, I hate working with people and I don't want to work with anyone, feel free to, you do not have to stick around on the Zoom. So if you want to leave the Zoom, you want to work on the problems, you want to rejoin class again at 3:20 when we all kind of come back together, I'm totally okay with that. I'm just going to let Zoom automatically, make the breakout rooms and stick people into them. So I'm going to make it so there's kind of 2 or 3 people in each breakout room. So that's the first thing. Secondly, if you are I totally get all these problems, you work on them, or you and your people in your group work on them, and you're like, yep, we're good, we know what we're doing, I'll check my answers later, and you don't want to come back at 3:20, that's okay too. So I kind of just want to put that out there. So it's kind of basically a session so that you can practice, but if you need help or you need me to explain something, then I'm here to help and explain it. So any questions before I break us all up into the breakout rooms? No. Okay. So if you don't want to be in a breakout room, you don't want to work with people, now's the time to leave, because I'm going to auto make the breakout rooms here in a second. So. Okay. Oh, whoops. Yeah, I do, Brian. I was just about, because you showed up in a breakout room and I'm like, wait, why is Brian in a breakout room? So wait a minute. Give me 1 second. I need to